All right, welcome to another deep dive. This time we're taking a look at a pretty crucial piece of code.
Yeah, you could say it's the backbone of our entire financial system. We're going to be getting to some really interesting stuff today. Think financial algorithms, experiments with AI, and even some, let's just say, questionable security practices. So strap in, everyone, because we're going deep. I'm a senior developer here, and I'm joined by our senior cybersecurity specialist. We're the dynamic duo tasked with debugging this beast and making sure everything runs without a hitch.
And let me tell you, just glancing at the sheer number of imported libraries is giving me pause. We've got a whole mix of web frameworks here, like FastAPI, Flask, Bottle, and even Quart. Then you throw in financial APIs like eFinance. And wait, hold on, is that PRA? For interacting with Reddit? That's a whole lot of moving parts. And with this many moving parts, well, there's a lot that can go wrong. Okay, Reddit, now that's interesting. But let's focus on what could potentially cause a complete system meltdown. I'm seeing functions here like DB Manager, and it looks like it has network scanning capabilities. It creates a tarball of database files, and then it uploads it to, wait a minute, is that a randomly generated public IP address?
It is. And not only that, but it's also posting the data to Facebook and Twitter. I mean, transmitting potentially sensitive financial data over the network and then broadcasting it on social media. Yeah, from a security perspective, that's a five-alarm fire. We need to understand why this has even happened in the first place. And more importantly, we need to find a safer way to handle this data.
Okay, moving on. What about this quantum encrypt function? Is this some kind of super advanced encryption that's going to keep our data safe from even the most determined hackers?
Well, the term quantum definitely sounds impressive, doesn't it? But it's actually a bit misleading in this case. The encryption method they're using here is elliptic curve cryptography, which, don't get me wrong, is a strong and widely used algorithm, but it's definitely not quantum. Marketing buzzwords aside, we need to verify that it's been implemented correctly. And we also need to make sure our keys are being managed securely.
Speaking of keys, I'm noticing that there are API keys and secrets hard-coded directly into the code. I mean, it's like leaving the keys to the bank vault taped to the front door.
Exactly. Hard coding sensitive information like that is a security nightmare waiting to happen. It means anyone who gets access to the code, even for a second, has access to those keys. And we absolutely cannot take that risk. We need to move those keys to a more secure location. Environment variables, a dedicated secrets management service, something like that.
So far, we've got network scanning, questionable data uploads, potentially misleading encryption claims, and hard-coded secrets. This is starting to feel like a recipe for disaster. Where do we even begin to untangle this mess?
All right, let's shift our focus for a minute. Take a look at this AI wrapper class. It seems like someone's been experimenting with artificial intelligence, which, on the one hand, it's interesting, but on the other hand, it introduces a whole new set of concerns.
Okay, the AI wrapper.
Yeah.
It looks like it's using several different neural network models. Like there's a simple neural network, a convolutional network, and a recurrent network. Is this where the code gets its financial, smarts?
Well, there's no doubt that AI has a huge amount of potential in finance, but the way these models are being implemented here, it feels a bit off. I'm not entirely convinced that the predictions these models are making are reliable, or even transparent for that matter. We need to understand what data they're being trained on, and what logic is driving their decisions. Otherwise, we're essentially trusting a black box to make critical financial decisions, and that's not a comfortable position to be in.
And to make things even more interesting, look at these pseudo comments scattered throughout the code. They mention things like facial recognition, social media scraping, and PII distribution. This is starting to feel less like financial software and more like some kind of dystopian surveillance tool.
Yeah, the implications of those comments are definitely concerning. We need to have a serious talk with the developers about the ethical boundaries of this code. We have to make absolutely sure that it aligns with our company's values and, of course, with our legal obligations.
Absolutely. This code is like a tangled web of financial algorithms, security risks, and questionable AI experiments. We need to carefully untangle each thread if we want to make this system functional and secure. We'll continue digging deeper into this code in the next part of our deep dive, so stay tuned.
All right, so picking up where we left off, we were looking at some, let's say, interesting AI practices and some Tudo comments that, well, hinted at some potential ethical issues. Let's move on to the computerist metrics function. It seems to have a rather, shall we say, unique feature.
Let me guess. It computes risk. Just kidding, just kidding. But seriously, what's so unusual about this function?
Well, it appears to have the ability to, and this is where it gets weird, delete itself. Self-modifying code is always a bit of a red flag in my book. It makes it much harder to track changes, understand how the code's behaving, and perform any kind of forensic analysis if something goes wrong. And then, of course, there are the security implications. I mean, if this function can just delete itself, what's to stop it from deleting other critical files?
Okay, hold on. A self-destructing function, that's not something you see every day. What triggers this self-deletion? Is it a timer? Some specific event?
It looks like it's based on a random probability calculation. If a certain condition is met, poof, the script vanishes. It's almost like this code is trying to cover its tracks, which is not exactly reassuring.
Yeah, that's pretty unsettling. Let's dive into this computerist metrics function and see if we can figure out what's going on. Is there any way to disable this self-destruct sequence?
First, we need to understand what this risk metric is actually measuring and what thresholds are being used to trigger this self-dilution. Once we have a better grasp of the logic behind it, we can determine if this functionality is actually necessary or if it's just adding unnecessary risk to the system. Maybe we can modify the conditions or introduce some safeguards to prevent accidental or, let's say, malicious self-destruction.
That sounds like a good plan. While you're working on that, I'm going to take a closer look at this update account balance function. It's recursive, and if it's not handled carefully, it could become a real resource hog.
Ah, yes, recursive functions. They can be elegant solutions, but they definitely need to be implemented with caution. If you don't have a clear stopping condition, they can quickly spiral out of control, consuming system resources like crazy and potentially even leading to a crash. It's kind of like a financial chain reaction. A small change can cascade into a system-wide meltdown.
Right, exactly. So let's see how deep this rabbit hole goes. Okay, it's calling itself repeatedly, and each call is increasing a depth variable. Here's the stopping condition. It checks if the depth is less than the result of this calculate financial indicators function.
And what does that function do exactly? Let's see. Okay, so it generates a random number. But the random number is based on a whole bunch of complex financial calculations. So the recursion just keeps going until the depth exceeds this random number.
So it's not exactly a predictable or reliable way to manage a critical function like updating account balances. We need something a bit more controlled.
Absolutely. Instead of relying on this random number, maybe we could introduce a fixed depth limit. That would give us a lot more control and predictability and prevent the recursion from running wild.
I like that idea. We could set a reasonable limit based on the expected complexity of the calculations and the system's available resources. That way, we can be confident that the function will complete its task without bringing the whole system down with it. Great. So we've identified the triggers for the self-destructing function, and we figured out a way to control those runaway account balance updates. What's next on the agenda?
Well, we still need to revisit those hard-coded API keys and secrets. Remember, they're like leaving a welcome mat out for any attacker who happens to stumble across our code. Storing sensitive information directly in the code is a huge security risk, and we need to address it ASAP.
Right. We can't just remove the keys entirely. The code needs them to function. What's a better way to handle this?
Instead of hard-coding them, we could store them in environment variables, or, we could use a separate configuration file.
Yeah.
That way they're accessible when we need them, but they're not embedded in the code itself, which makes it a lot harder for attackers to get their hands on them.
And to add an extra layer of security, we could encrypt those configuration files, or maybe even use a dedicated secrets management service.
Absolutely. When it comes to security, layers are your friend. The more layers you have in place, the harder it is for attackers to breach your defenses. All right, now let's go back to that DB manager function and those interesting data uploads.
You mean the function that scans the network for databases, creates a tarball, and then uploads it to a random public IP address and social media? Yeah, that one still has me scratching my head.
We need to figure out the purpose of this data collection and those uploads. I mean, is it for legitimate backups, analytics, or something a little more nefarious? Until we know why this data is being handled in such a reckless way, we need to disable those uploads. Transmitting potentially sensitive data over the network and to public platforms is just way too risky.
I agree. It's better to err on the side of caution. We can comment out the code that sends the data to the random IP address and the social media APIs, at least for now.
Exactly. And once we have a better understanding of the intended purpose, we can explore some more secure and appropriate data transfer mechanisms. Maybe we can implement encrypted connections, use a trusted cloud storage provider, or restrict data access to only authorized personnel.
Okay, so we've addressed the self-destruct sequence, the recursive black hole, those hard-coded keys, and the let's call it data exfiltration.
Yeah.
What's next on our debugging to-do list?
Well, now we enter the fascinating and potentially perilous realm of artificial intelligence. Remember that AI wrapper class with its ensemble of neural networks? That's where we'll be venturing next.
All right, let's explore this AI mystery. It sounds like we're in for a wild ride. All right, welcome back for the final part of our deep dive. We've made it through some pretty treacherous security vulnerabilities, managed to tame that runaway recursion, and now it's time to face the enigma that is artificial intelligence. Remember that AI wrapper class, the one with all those neural networks? Well, we're about to unravel its mysteries.
You know, the AI wrapper really highlights both the incredible potential and the inherent risk of using AI in finance. Our job here is to understand exactly how these models are making decisions. And then, of course, we need to ensure that those decisions align with our company's values and, its risk tolerance. We can't just have black boxes making critical financial decisions without any transparency or accountability.
Right, absolutely. So let's start with the basics. The AI wrapper seems to incorporate three different types of neural networks: a simple neural network, a convolutional network, and a recurrent network. What are the strengths and weaknesses of each model? And why would someone choose to use all three in the same system?
Well, each neural network architecture has its own unique characteristics, making it suitable for different tasks. A simple neural network, sometimes called a feed-forward network, is the most basic type. It's good for tasks that involve mapping inputs to outputs in a straightforward way, like classifying data or making predictions based on numerical features.
So it's kind of like a simple equation where you plug in the numbers and get a result.
In a way, yes. But the real power of a neural network lies in its ability to learn complex relationships between the inputs and outputs from data. It can adjust its internal parameters, or weights, to improve its accuracy over time.
Okay, that makes sense. What about convolutional networks? What are those good at?
Convolutional networks are really good at processing data that has a grid-like structure, like images or time series data. They use a special type of layer called a convolutional layer that can detect patterns in the data by sliding a small filter over it. This makes them particularly useful for tasks like image recognition, object detection, and natural language processing.
So if we were analyzing financial charts or graphs, a convolutional network might be a good choice.
Exactly. It could learn to recognize patterns that might not be obvious to the human eye, like trends in stock prices or anomalies in trading data.
Interesting. And what about recurrent networks? What are those best suited for?
Recurrent networks are designed to handle sequential data, where the order of the elements is important. They have a built-in memory mechanism that allows them to remember information from previous time steps, making them suitable for tasks like language modeling, speech recognition, and time series forecasting.
So if we were trying to predict future stock prices based on historical data, a recurrent network might be the way to go.
Precisely. It could learn the temporal dependencies in the data and make predictions about future values based on past trends.
Okay, so each of these neural network types has its own strengths and weaknesses. But why would someone use all three together in the same system?
There are a couple of possible reasons. One is that the different models might be used for different tasks within the system. For example, a simple neural network might be used for classifying customers, a convolutional network for analyzing charts, and a recurrent network for forecasting stock prices.
So it's like having a team of specialists, each with their own area's expertise.
Exactly. Another reason is that the models might be combined in an ensemble to improve overall accuracy. By averaging the predictions of multiple models, you can reduce the risk of any single model's biases or errors dominating the results.
So it's kind of like getting a second opinion or even a third opinion to make sure you're making the best possible decision.
That's a good analogy, but there's a catch. Ensembles only work well if the individual models are diverse and uncorrelated. If the models are all making the same mistakes, averaging their predictions won't help.
That makes sense. You need a variety of perspectives to get a truly well-rounded view. But now I'm wondering, how do we even know if these AI models are actually making good decisions?
Yes, the million-dollar question. Evaluating the performance of AI models is crucial, especially when they're being used for critical tasks like financial decision-making. We need to establish clear metrics for success, like accuracy, precision, recall, and F1 score, depending on the specific task.
And we also need to make sure those metrics are aligned with the real-world goals of the system. What good is a model that can predict stock prices with 99% accuracy if it's making predictions that are consistently too high or too low?
Exactly. We need to evaluate the model's performance in the context of the specific problem we're trying to solve. We also need to be aware of potential biases in the data used to train the model.
Biases in the data. What do you mean by that?
If the data used to train the model is biased, the model will learn those biases and perpetuate them in its predictions. For example, if a model is trained on data that reflects historical discrimination in lending practices, it might unfairly deny loans to certain groups of people.
That's a scary thought. So how can we ensure that the AI models we're using are fair and unbiased?
There are a number of techniques for mitigating bias in AI models. One is to carefully curate the training data to ensure it's representative of the population we're interested in. Another is to use fairness-aware algorithms that explicitly account for potential biases during the training process.
So it's not just about building accurate models, it's also about building ethical models.
Absolutely. As AI plays an increasingly important role in our lives, it's crucial that we develop and deploy it in a responsible and ethical manner.
Well, we've covered a lot of ground in this deep dive. We've explored security vulnerabilities, tamed runaway recursion, and delved into the complexities of artificial intelligence. Any final thoughts?
I'd say the key takeaway here is that security is paramount. Always assume that someone is trying to exploit your systems and take the necessary steps to protect your data and infrastructure.
And when it comes to AI, remember, it's not magic. It's a powerful tool that can be used for good or for bad. We need to be mindful of its limitations, stay vigilant about potential biases, and always put ethical considerations first.
And of course, never stop learning. The world of technology is constantly changing, so stay curious and keep exploring.
Yeah. Couldn't have said it better myself. And that brings us to the end of our deep dive into the code that powers our financial world. If you enjoyed this episode, be sure to like and subscribe for more insightful journeys into the digital frontier. We'll see you next time.